Bismillah ar-Rahman ar-Rahim, in the name of God, the most gracious, the most merciful. Welcome to Lady Khadija Radiallahu Anha Online College. Live lesson, A-Level Maths Year 2, Pure Maths. It's composite functions, carrying on from a lesson we've done just recently. Okay, let's begin. Okay, Bismillah ar-Rahman ar-Rahim, in the name of God, the most gracious, the most merciful. Today we have a function which we're going to call f, and another function which we're going to call g. But rather than write it as f bracket x, I want you to get used to, in this example, we're getting you used to different ways of writing it. So a function can be spelled in as a word, F-U-N-C-T-I-O-N, but mathematicians don't really like writing words. So f bracket x, that's an easy way of writing the function of x. Another way of writing the function of x, it means exactly the same thing, is to do f, two dots, and then x, and then an arrow, and then the function or the equation, so 2x minus 8. What you need to see, what you'll see between the x and the function is an arrow. So remember, a function is also called a mapping, and a mapping just means we're taking one number and turning it into another number using a bit of algebra here. But once the algebra is done, what you get at the end is a number. So we're taking one number and putting it and turning it into another number. So that's what the arrow is signifying, and that's called a mapping. The x maps to an answer that we'll get from doing 2x minus 8. And just to make it a bit harder and try and make sure you remember what you've learned about modulus functions, the example today starts off with a function which is a modulus function, 2x minus 8. Remember, you can handle this a couple of ways, and the easiest way is to do it on a graph. And if you're more comfortable with the algebra, then you remember that anything that's positive with the mod as an answer will stay positive. Anything negative will change to become a positive. Okay, let's take a look at the next function. Again, we're going to just change it from g bracket x to g colon x. The colon means such that. So the function g is such that means it applies for turns x into x plus 1 on the top and 2 on the bottom, so x plus 1 over 2. So the function g is such that x's change to x plus 1 over 2. So far, no math really that's new. It's just the way we're writing it. It's the same maths as before. We're using a function, and the first function's 2x minus 8 with modulus on the end. Around it, the other function is x plus 1 over 2. We're calling the first function f, calling the second function g. We're just writing in a bit of a different way. So now the good thing is the question is written as you're normally used to it. So it's work out fg3. So if you remember, we're going to work from right to left, from the back. So reading it this way, we're putting 3 into the function g. And whatever that answer is, we're then putting it into the function f. So let's start with function g and put 3 into it. So 3 plus 1 over 2, that would just become 2. And so I can say g of 3 is equal to 2. And now I want to put that g of 3, which is the 2, I want to put that into the function f. So that 2 has to go into this function f. So let's grab a copy of that function, and we want to put the 2 where the x is. So the 2 will go here. So that's 2 times 2, that makes 4. Take away 8. 4 take away 8 is minus 4. So I'll have minus 4 on the inside here. And these two lines around it just means modulus, that negatives will get erased. So this will just equal 4. Okay, that's the warm-up really. The next one is going to be more challenging. So here we want to try and do a little bit of algebra, but also represent it on a graph as well. So the question is, can you solve f g x equals x? So here we want to come up with an equation. We're going to have x on the left, sorry, x on the right, and on the left of our equation, we're going to have to figure out what the algebra is going to be. We need to put the function g into the function f, so making use of what we did yesterday. And then we need to solve that. So let's try that. We're taking the function g and we're putting it into where we'd normally put numbers, into the x bit of f. So that means starting with, so the g, this whole bit goes into the x. So I'll have the line, the 2, and then this x will change. So I'll have the line, the 2, and then instead of writing x, I'll have this x plus 1 over 2. So I'll have x plus 1 over 2. And then comes the minus and the 8 and the end of the modulus sign. So that's what we're working on this bit here, fg of x. So let's, and on the right hand side will be equals x. So that's going to be equal to x. Okay, let's tidy up the left hand side. The 2's should cancel out. So I'm just left with x plus 1. I can drop the brackets because now the 2's are cancelled. There's nothing on the outside. So I'll have x plus 1 take away 8. X plus 1 take away 8. The 1 take away 8 can make 7, but minus 7. So I can replace the plus 1 and the minus 8 for minus 7. So I'll have x take away 7 on the inside. Is equal to the modulus of x take away 7 is equal to x. So how do we solve this? If you remember from a couple of lessons ago, we can draw a grid, we can draw a graph, and we can plot the graph on the left and the graph on the right. So we can think on the right we have the equation y equals x, and that's just a straight line through the origin at 45 degrees. On the left hand side, forget the modulus for now, but x take away 7 is a line that goes through the y-intercept at minus 7, and the gradient is 1 because x really means 1x. So it'll be something like that. Just continue that on for a bit more. So minus 7 here is your y-intercept. And then what happens with the modulus is that we have to reflect anything above the x-axis stays as it is, but what we can't have is negatives. The negatives would get changed into positives. So this area here for the line in orange is going to have to flip. And I don't want the black line to flip, so I'll draw that again in a minute. But if I just redraw that orange line, and what I want is the orange line to flip So let's flip that, and we want it to flip. That's it. So when I'm bringing that back up, that's how the graph will look. So that's the graph of y equals the modulus of x minus 7. Do you remember the other graph that we had? What did that look like? So the other graph we had was y equals x for the right-hand side. So let's do that. Again, we had it before, but I just needed to remove it. Okay, good. So now we need to solve that equation. So how will the graph help? It'll just tell us whereabouts we're looking for an answer. We're looking for an answer here. That's where they intersect. This answer is important because on the black line, that's just going to stay normal. But what we notice is on the orange line, the line of y equals x, the solution is on the part that we flipped. So what that tells you is that we're going to have to treat the modulus with a minus on it. We can't just ignore it completely as if it was positive because the solution's not on the positive bit. The solution's on the flipped bit. So what we need to do in order to do the algebra is replace the modulus sign with just a minus and then the brackets. And now that's easy to solve. We can expand the brackets. Minus x plus 7 equals x. Take the x's to one side. 7 is equal to 2x. And then solve for x equals 3.5. We also want to give the y coordinate really, but you can do that by just substituting into the graph y equals x, the equation y equals x, and you'll find out y is also equal to 3.5. Let's just check if there's anything more on that. No, that's it. So quite a difficult question to finish off with, but let's just see if you got the basics. Firstly, starting from here. So how do I know what goes on the left-hand side? You've got the beginning bit, so you can see the big clue here. It's starting with a modulus and then a 2. But then what goes next? Do you remember? Okay, good answers so far. This is the key bit to see whether you've picked this up. Okay, good. The whole of the g function goes where the x should go. So normally after the 2, we'd write the x. Here we're not going to write the x because we want the g function to go there, because it said reading backwards, g into f. So that means the x plus 1 over 2 goes there. The rest of the f function carries on with the minus 8 and the modulus. Then do we stop there, or is there something more to write on that line? I've worked out what fgx is, so isn't it all right just to stop there? Good, equals x. We're trying to make it into an equation because that's what we're trying to solve. So equals x. Then we tidy up, the 2's cancel. Sorry, that was a bit too quick. Then we tidy up and we see the 2's cancel. The brackets can go. The plus 1 minus 8 can turn to minus 7. So I just end up with x minus 7. And now the graph will help us picture where the solution is. But once we've figured out that the solution is here, then what does that tell me to do with my equation, particularly the modulus side of things, knowing that the solution is there? Okay, this was a key bit. So let's see what Aisha is saying. So keep the negative, not keep the negative, but put a negative instead of the modulus sign. So because we're on the flipped part of the orange graph, it means that we have to treat the modulus with care. It means we can't just drop the modulus completely as if the answer was a positive. Because it's on the flipped part, we need to handle it with the other option, which is you put brackets around it and you put a minus at the front. So that's where you get the brackets around and the minus at the front and then solve as normal. Okay, if that was a little bit hard, have another watch of the video and inshallah, God willing, you'll get it. Join me again next week for more work on functions. Assalamu alaikum wa rahmatullahi wa barakatuh.